Hi, students. Today's video is by Ms. Lily Wu, TAMU class of 2024. She recorded this video as part of an honors project she did for this class. Lily, take it away.
Howdy, students. In the last video, we showed you how the controlling factors for carbon dioxide emissions have changed over the past few decades. If we can predict how these controlling factors will change in the future, then we can predict emissions, which in turn allows us to predict future climate. So we need to make predictions of all these factors, but predictions are hard. No one in the 1980s would have predicted the rise of China as an economic superpower, and the 2000 US presidential election between George W. Bush and Al Gore came down to a few hundred votes in one county in Florida. The winner was essentially a coin flip, yet it also seems certain that the world today looks completely different from the world we would have had Al Gore won the election. So making a single confident prediction of future emissions would be foolhardy. Because of that, scientists have developed a set of future emission scenarios that take into account the various ways the world can evolve. Each scenario represents one possible way the world could evolve in the future, and the set of emission scenarios should span the total potential range of emissions. So each of these scenarios must also be internally consistent, meaning that population, affluence, and technology don't vary independently. For example, studies of fertility show that women have fewer kids as society gets richer, so scenarios with higher economic growth should feature a lower population. Thus, scenarios with smaller increases in affluence should have populations increasing more rapidly than scenarios with larger increases in affluence. This slide shows that the poorest countries in the world also have the highest fertility rates, which is the average number of kids each woman has during her lifetime. Richer countries tend to have lower fertility, so some can even see a decrease in populations if the fertility rate gets below 2. So the reasons for this are also discussed in the textbook. Now, affluence can also affect other factors that control emissions. Both energy and carbon intensity are connected to affluence because the development and adoption of new technology, which reduces energy and carbon intensity, requires a certain level of affluence to support it. So the scientific community has done a prediction exercise and created the Shared Socioeconomic Pathways, abbreviated SSPs. Each one is a prediction of the emissions of how emissions might evolve over the 21st century and beyond. So there are 5 scenarios. They are SSP1, SSP2, SSP3, SSP4, and SSP5. Given the predictions of population, affluence, technology for the storyline underlying each scenario, we can predict estimated emissions. So this plot shows that, and we can see that SSP4 is not on the graph. That's because it's not widely used, and so we're just not going to discuss it any further. So let's start with SSP1. SSP1 focuses on sustainability and equality. So the wealth gap closes and population growth slows, as one would expect based on the relationship between wealth and population growth. The world shifts towards renewable energy, and as a result, the emissions are lowest for this scenario. Emissions peak around today, so around 2020 or 2021, and then they decline throughout the rest of the century. And we can also notice here that emissions actually go negative around 2075. So this means that humans are pulling more carbon out of the atmosphere than they are releasing. Next is SSP2, and this is a middle-of-the-road scenario. So this world follows a path in which social, economic, and technological trends are similar to historical patterns. SSP2 is therefore an extrapolation of the world we live in today. So emissions peak around the middle of the century, and then they decline thereafter. SSP3 is a world full of regional rivalry and inequality. The wealth gap increases, leading to conflicts, and nationalism is also on the rise. Population growth is rapid in poorer countries, leading to the largest global population among the SSPs. So because wealth growth is slow, technological development is slow, this leads to a reliance on high carbon intensity resources like coal. Overall, this is the least wealthy world, but because of the large population and reliance on fossil fuels, emissions are also very high. Lastly, SSP5 is a rich world similar to SSP1, but it's one that relies on fossil fuels rather than sustainable energy. So because of the high wealth and reliance on fossil fuels, emissions are also very high, and they reach about 126 gigatons of carbon per year by the end of this century. So this is about 3 times today's emissions. So as you can see, the different worlds described by the SSPs have very different emissions. The best interpretation of this set of scenarios is that they span a range of possible future scenarios. So you might also notice that there's numbers following the dash of the SSP names right here. And this equals the amount of radiative forcing in 2100. So SSP 126 equals 2.6 watts per meter squared of radiative forcing into the 2100. So this is also described in more detail in the book. So now we can run these emissions through a carbon cycle model, which calculates how much carbon is removed from the atmosphere and transported into the ocean and land biosphere, which we discussed in chapter 5. So this plot shows what we expect atmospheric carbon dioxide to look like. This plot right here. So we have the lowest emissions with SSP1, and which also means that we have the lowest amount of carbon dioxide in the atmosphere. And then we have SSP5 on the other hand, which has the highest emissions and highest amount of carbon dioxide. So as carbon dioxide increases, we have to remember that N in our favorite equation is increasing, so we expect this to warm the climate. We can then use sophisticated global climate models to make this projection of carbon dioxide and make quantitative estimates of how the climate will change. So this plot right here shows the prediction of future climate change. This plot says that under the worst case SSP5 scenario, the world may be about 5.5 degrees Celsius warmer than pre-industrial times, while under the lowest best case scenario, SSP1, it may only be about 2 degrees Celsius warmer. Another noteworthy point is that despite the huge differences in emissions, the scenarios predict relatively similar warming until they begin to diverge around 2040 to 2050. This means that the temperature trajectory over the next few decades has already been largely determined by emissions that may have already occurred. But while we don't have much control over the warming in the first half of the century, we do have a lot of control and significant influence over the amount of warming experienced during the second half of the century. So this is one of the many aspects of climate change that make it difficult to solve. Addressing climate change will require us to make investments now and in the next few decades in our energy system. But these investments will only really affect the climate in the second half of the century. So in politics, this is called a tough sell. So to summarize, we predict a warming of a few degrees in the coming century. This may not seem like a lot, but it's actually a huge amount of warming. Remember that in chapter 2, we learned that the last ice age was about 6 degrees cooler than today. So warming of a few degrees can remake the entire planet. In chapter 9, we'll also discuss this further. So while the climate in the next few decades is already largely determined by past emissions, we can also see that the choices we make today will have a big impact on the climate in the second half of the century. So in other words, we still largely control how bad climate change will be. It's also worth noting that you and I, and Dr. Dessler as well, may very well live through this next century, so we do have a lot riding on whether or not we follow through a low or high emission scenario. So in the next video, we will be talking about the potential evolution of the climate beyond 2100. And now, your moment of squirrel.
Heck? Oh, so sweet. You want it? I have nothing.
And you're gonna get attacked.
No, you just wanted food. That was so cute.